From the Palacious IB studios of the Way Happy Labs, this is Mr. Meyer, and we are talking about exponential equations using logarithms. So let's get started. Earlier, we found that if you had an exponential equation, remember like something like 8 to the x equals 64. If you wrote them in the same base, it made this a lot easier, right? You were like, hey, 8 to the x equals 8 squared, or maybe you put it base 2, but you told me that x was 2 and life was good. But bad news is that's not always easy to do. It's not always easy to be able to write them in the same base. So we need another method, hence enter logarithms, which we do know are the inverse of exponentials. So look at example 1. Consider the equation 2 to the x equals 30. Dang it, if it was 32, we could have written that as 2 to some power, right? However, we can't. So we can kind of guess, right? Let's see, 2, 4, 8, 16. 32 is 2 to the 5th, so it's a little less than 5 is all I can tell you. But that's it. That's a little helpful, but not super helpful. So let's go ahead and solve this, again, by using logarithms. So part A and part 1, they say let's do it with base 2, which makes sense, because if somebody gives me 2 to the x equals 30, then remember, there's two ways to solve this. You can either do your g-force, go ahead, rewrite it, whatever you want to call it. The exponent you put on 2 to get x is a 30. You can rewrite it in logarithm form. Or I think a nice easy way too is to log both sides, and they want me to use log base 2. So I will log base 2 this side, and now I got to kind of sneak it in, so I'm going to sneak it in. Log base 2 of 30 on this side, right? The rule on exponents is now that this can come out in front, and you have x log base 2 of 2 equals log base 2 of 30. Log base 2 of 2 is 1, and there it is, log base 2 of 30. That is the exact answer. You're like, wait, put it in a calculator. Calculator is going to give me an approximation. Why? Because it can't go on forever. This number will probably go on forever. It's not a very pretty number. So that's our exact answer. Right? The exact answer is log base 2 of 30. What about log base 2? What if we do log base 10? What would that mean? All right. Well, I would do the same thing. I would start off with 2 to the x equals 30. And then I would log this side. And I would log this side. Notice I used base 10 this time. So what happens? The x comes out in front. X equals log 2 equals log 30. Now realize that log 2 is just a number, some gross number on your calculator. Log 30 is just some gross number on your calculator. But x is your variable, so let's divide that log 2 over, and we get x equals log 30 over log 2, and that's it. That's as far as I can go, because again, put it in your calculator if you want. You're going to see it's a nasty decimal that goes on and on and on, and your calculator will quit at some point, so that's why it's an approximation and not exact. All right, part B. Well, if we solve this problem twice, we solved the same problem twice, and we got different answers. And the only thing we might want to comment on is, hey, I solved the problem twice and I got different answers, which means log 2 of 30 must equal log 30 over log 2. If anyone knows the change of base formula, I'll say it quietly, change of base. It's like an ASMR video. If anyone knows that, then I bet they're setting that up. All right, so interesting to notice log 2 of 30 is equal to log 30 over log 2. All right, what about find exactly? Find exactly again. So now we're going to use Euler's number, E, and we're going to try to go ahead and solve these bad boys. All right, let's try it. Find x exactly. E to what power is equal to 30? I don't know, but how could I cancel out, or how could I undo the e to the power? I know. I could use a natural log. So if I natural log this side, and I natural log this side, that's legal in math, right? And then the x comes out front, and the natural log turns into 1, and there you go, it's ln of 30. Nice! What about the next one? Might be a little trickier. So what would I do? I think I would divide by 3 first to get e to the x over 2 equals 7, because why is the 3 hanging out over there anyway? He should be over with the 21. So they're both constants. Move them over. Done. All right, now I'll natural log both sides. Ln and ln, right? And this is why I like natural logging, by the way. See how easy it is to put an ln in front of stuff? Oh, so much prettier. And then I get x over 2 is equal to ln of 7, which now I could multiply the 2 over and get 2 ln of 7, and there's all my constants on the right. And some of you are probably saying, hey, wait, couldn't I even make that ln of 49? And you could. I wouldn't mind. So I think either of those answers would be fabuloso, right, for x. All right, let me ask you a question, and I'll be right back. All right, I really love the effort you put into there. Keep up the good work. All right, consider the equation p equals 200 times 2 to the 0.04t, and probably represents something, a population I'm going to guess is p. Rearrange the equation to give you t in terms of p. Ooh, we got to bring an exponent down. That's going to involve logs. I'm so excited, I can hardly control myself. All right, oops, I don't want to use that color no more. So I'm going to go p is equal to 200 times 2 to the 0.04t. All right, first thing I want to do, I want to get t alone, so I'm going to have to work with that, but I need this 200 out of here, which is a quick and simple division problem, right? So now I have 2 to the 0.04t. All right, now the scariness. We need to get rid of that. So you got options here. You got log base 2, which is a good one. You got natural log, which is my favorite. You got regular common log, which is a button on your calculator. So, hey, maybe that's a good one too. So I am going to go ahead and actually use common log, even though in all honesty, I would probably use natural log in the real world. But just to get you started, I'm going to go, let's go log base. Let's go log base 10, or the common log. So I'm going to log both sides. And as I do that, I now have log p over 200 is equal to 0.04t log base 2. All right, then I can go ahead and divide, yuckily, by the stuff that I don't want. I want t all by himself. And so the stuff that has to be divided over is the 0.04 and the log base 2. So as I do that, I will get log of p over 200 over 0.04 times log base 2. And there is my answer in terms of t. All right, what about if they want me now to find a t when p is 6? All right, piece of cake. So part A is done, check. Part B says, all right, do it when p is 6. So I need Sheila here. And I'm going to grab the calculator and I'm going to say, all right, I'm just going to plug it in. That's why I picked log, by the way, is so I could use my calculator. So, and again, natural log would work just as well. So 6 divided by 200 is that, right? And then I'm going to divide that all by, I'm going to put parentheses around the denominator to keep it together, 0.04 log times log of 2. And Sheila says that this answer is negative 126.472. So there you go, negative 126.472. So t is approximately equal to negative 126. I forget what I said. 472, whatever's. I don't even know if they told me if it was seconds or minutes. But there you go. If we were going to go 3 sig figs on this, by the way, we would just go negative 126. All right, now let's try this last example. Find the exact points of intersection. All right, exact points of intersection. Probably going to have the word log in them again. And how do I know that? Because I see some exponentials over there. Points of intersection, that's when the two equations are equal. And luckily they both say y equals. So the good news is I'm just going to say e to the x minus 3 is one equation. And when does it equal 1 minus 3 e to the negative x? Oh, doctor, this looks like it's going to be a little bit of work. So first thing I want to figure out is how on earth am I going to solve this? And I don't like that negative x. That's confusing me for a brief second here. The 1 and the negative 3 are also kind of annoying. So I think I'm going to combine them real quick. So I can make this e to the x minus 4, if you don't mind, equals negative 3 e to the negative x. But that's about where I'm stuck. So in my head, I'm thinking e to the negative x is 1 over e to the x, right? That's what that is. So if I think of this as e to the x minus 4 equals negative 3, and really I could just put e to the x on the bottom, because that's what that meant, then I might be a little more comfortable, because what do you think I should multiply both sides by? We don't like fractions, so let's multiply both sides by e to the x, or in other words, let's multiply everything by e to the x. That will cancel that fraction when it gets there. So first part, I would have 2 of those, or squared, so e to the 2x. Then I would have minus 4 e to the x, and then those would cancel, and I would have minus equals a negative 3. And lo and behold, this is starting to look pretty good, right? If I move the 3 over, this is starting to look very much to me like something that is factorable. Let Let me break it down one more time. I think we've done this before, but if I say m is equal to e to the 2x, I'm sorry, e to the x. So I say that's a bad let m equal e to the x, then that would be m squared minus 4m plus 3, which factors down to m minus 3, m minus 1, right? Because they multiply to 3, they add up to negative 4. So coming back to the original problem, you might notice that I would have changed the m back to e to the x. I'd have e to the x minus 3 and e to the x minus 1 equals 0. And now I could solve those beautiful problems. Let's see. When does e to the x minus 3 equal 0? Well, that's when e to the x equals 3. And if you wanted me to find that answer, I would natural log both sides and get x equals ln of 3. So there's one answer. When does e to the x minus 1 equal 0? Well, that's when e to the x equals 1. And if I log both sides, or actually that's kind of easy, when does anything to a power equal 1 is when x is 0. So when x is 0. Or you would have got that too if you would have natural log both sides. You would have had the same solution. So the two answers are ln of 3 and 0. Now, I think they said, find the points of intersection. So now we got to plug those back in and figure out where they are, right? So the two answers that I would get, so when x equals 0, you get the point of intersection. Let's see, let's plug it in the first one. Anything to the 0 power is 1, so 1 minus 3 is negative 2. You get 0, negative 2. And when x equals, what was the other answer? ln of 3. You get ln of 3 is your x, and what would you get if you plug it in? ln of 3 would be 3 minus 3 is 0. Oh, interesting. So there are your 2 points of intersection. All right. I'll ask you a question, but have a great day. No, and I'll be right back because we have another section. All right, how about the change of base rule? All right, you got it. Change of base, you've seen it, you love it, let's do it. All right, change of base rule goes like this. Log base b of a is equal to log of any base you pick of a divided by log base c of any base you pick of b. And this will always work. And so you've seen it already, we kind of hinted to it in the video earlier, but here it is now in final form. It's probably in your book, so you don't have to worry, or your formula book, so you probably don't have to worry too much. But let's go ahead and solve this. Look at the first part. Part A, log base 2 of 9 is equal to x. You could rewrite using g-force. You would get 2 to the x equals 9, right? And so that is one way to do it. Or you could just use your graphing calculator and go ahead and solve it. We could also change the base if we wanted to. Now I could log both sides base 10, because maybe you're like, oh, I don't know how to change the base before. So I log both sides base 10, right? And I get x equals log 9 over log 2. And if I do that, my graphing calculator will give me an answer. So, no, don't go big screen. I only have 2 minutes. Let's go log 9, close that parenthesis, divided by log 2. Where's log? Log 2. Don't have to close that one because it doesn't matter. 3.16. What about if I go base 10, which is actually kind of what I did, but what I would do here is I would go ahead and change log 2 of 9 using change of base formula, which would be log 9 over log 2, which is what we just did. So you know that answer is the same. What about if I go base E, log 2 of 9? I want to change it to a natural log because I like that button better. So I'm going to go ln of 9 over ln of 2 according to the change of base formula. And if you look at what Sheila says that is, let's go ln of 9 divided by ln of 2. And Sheila tells you the answer is also. So notice there, the calculator is agreeing with us that change of base formula is fabulous and works well. All right, so how could I do that here on this last one? All right, let's see. I have this beautiful problem, and oh goodness, what am I going to do? I don't even know. There are 2 different bases. Wait, are they really 2 different bases? This is 2 cubed to the x, right? Minus 5, and then 4 is just 2 squared to the x. Wait a minute, they're both the same. They're both a base of 2 of something. So I could factor that out and actually solve this. So I'm going to pull out a 2 to the 2x. Right? I would be left with, if you divide that by 2 to the 2x, you would have what? 2 to the x minus 5 equals 0. And now the zero product property says set them both equal to 0. Well, this one can never ever happen. right? But this one can. 2 to the x equals 5. That can happen, and I can log both sides, or I could do